This is the second video on sets that I'm doing for my IB classes. If you haven't watched the first one, I would strongly recommend it. Okay, so what we're going to do is we're going to start giving official names so that we can use them and know the terminology and the symbols that we're going to see as we move forward. The first one is an N with an extra line. Now, my guess is that you've seen an R with an extra line, and I'm going to get there in a second, but this N with an extra line are known as the natural numbers. Okay, and depending on the author of the book, sometimes, basically, let me try that again. The natural numbers are the counting numbers, but some books include 0 and some books don't. So in our IB world, we do include 0. So we're going to say it's 0, 1, 2, 3, and we're going to go off to infinity. So these are the positive integers and 0. I have seen books that don't include 0, but we're going to. The next set, we use a fancy letter Z, and those are the integers. Okay, so that would be the set. Sometimes I'll write it and I'll say, okay, it's -2, -1, 0, 1, and 2, and then we keep going. Or you might say it's the set 0 plus or minus 1, plus or minus 2, plus or minus 3, and so forth. Okay, so those are the integers. They're positive and negative numbers and 0. If you see something like this, if it has a Z with a plus sign up here, that means they want the positive integers. So they would start with 1 and move forward. If I see, so that's the set 1, 2, 3, so forth. If I see with a negative up here, that's a Z. It's trying really hard to be a Z. Then that one is going to be all the negative integers. So -2, -1 would be kind of the end of that. So it kind of goes from negative infinity all the way up to -1. That's what we're looking at there. The next one are the rational numbers. And we use a Q with an extra line to mean the rational numbers. Okay, and rational numbers are any number that can be written as a fraction. So anything where I can write P over Q, where P and Q are elements of the integers. Notice we use that symbol that we just talked about in the previous video. So it could be like 3/4 or -1, 2, 3 over 4, 5, 6. I don't know, I just made something up. Okay, anything that can be written as a fraction. So now, and if I want, what do you think that means? This not notation right here means they're not net rational numbers. These are the irrational numbers. Okay, so then the last one for SL are the real numbers, and that looks like this. And so that can be anything that you can put on a number line. So if, basically it's everything but imaginary numbers. So here's our symbol for real numbers. And my HL kids, you're going to have to enter the complex world, and so that's a C with an extra line. SL, we keep it real. Okay, so real fast here, if I have, nope, I'm going to not do that yet. Okay, so I want to put all of these in a Venn diagram. So the smallest set were the natural numbers. So that's that N with an extra line. And I have something like 4 or 11 or something like that, and 0. The next bigger set are the integers. So all of these natural numbers also live inside the world of integers. And say -17 is out here, and -1, 2, 3, 4, 5 is also out here. I don't know, I'm just picking something. That lives entirely inside the world of rational numbers. So something that's not inside of one of these two things would be like 1/2 or -3/7 or any fraction that I can come up with where the numerator and the denominator are integers. And then that lives entirely inside the world of real numbers. So we might have pi. If you remember, pi is approximately 3.14, but it can't be written as a fraction. If you see 22/7, they've estimated. That's not the exact value of pi. I could have, say, a -√5. That would be, it's a real number, but it's not a rational number. E would be a real number, or I could even say 1 plus E would be a real number, but it's not rational. Okay, and that is the world that SL is going to live in. HL, you're going to come on out here also to the complex. And everything that's real could also be written as a complex number. You could think of it as there's also this world here of imaginary. And so like 4i could be here, but then stuff out here could be like root 3 minus I root 7. So basically the complex world is in the form a plus bi. And if b is 0, that means that it's just got a real part, and that keeps you inside this circle. If a is 0, then that means you just have the imaginary part, so you're kind of in that world. But if you have an a and a b, something like this, that puts you, or 1 plus 2i would be complex. But they all live inside the world of complex numbers. Okay, hopefully that's helpful. I'm going to make one more video on interval notation, so stick around.